When you're working pump efficiency problems, you're typically given current and voltage in order to help you find the energy put into the system. When you do your pump testing, you have to connect your pump to a power source, and you'll also have to connect your multimeters. This problem here illustrates the connections for the multimeter to the pump motor. It is asking us to determine which ones are correctly connected in order to measure the voltage and the current. Let's look at each one and see if we can determine the options that are correctly connected. In order to understand which multimeters are correctly connected to the pump motor, we have to understand how you measure current and how you measure voltage using the multimeter. When you measure voltage, you're measuring across components. Remember, voltage is the potential difference between the electron supply and the electron shortage, and therefore you need to measure across a component to get that difference. So when we're looking at the multimeter for voltage, it needs to be measuring across the component of the motor from the positive to the negative side. On the other hand, when you measure current, you need to connect the multimeter to be part of the circuit. That current needs to flow through the multimeter in order for you to measure the current as it passes through the circuit. So let's look at option 1 and see if we can determine whether or not the multimeters are connected properly. First, let's look at voltage. This multimeter is measuring voltage. You can see that the dial is set to volts. And if we look at where the multimeter leads are, we can follow along those leads and see how they are connected. Looking at the yellow lines that I've drawn on the screen, you can see that those multimeter leads are connected across the components. You can see that you have a point here on the positive side, and you have a point here on the negative side where that multimeter is measuring. So the voltage is properly connected. Now we have to test and make sure the current is also properly connected. When we look at the multimeter that's measuring current, we see that the multimeter leads are connected as part of the circuit. You can see that that current would have to flow through this multimeter in order to complete the circuit. Therefore, this multimeter is properly connected in order to measure current. So I can say that option 1 is a correct solution. Let's move to option 2. Again, starting with the voltage multimeter, we can see that the multimeter leads are connected on the positive side of the pump and the negative side of the pump, which is then measuring across that component. And so the voltage is connected properly. Let's look at the current multimeter. The current multimeter, just like the voltage multimeter, is measuring across the component from the positive to the negative. You have a lead that's connected to the positive and you have a lead that's connected to the negative. That is incorrect. That is not how we need to measure current. Remember, current has to be part of the circuit. So you actually have to open up that circuit and connect the multimeter leads so that current can pass through that multimeter in order to complete the circuit. So I know that option 2 is not a correct option. Let's move to option 3. Again, starting with the voltage, we see that the multimeter leads are connected as part of the circuit. That means that they are in series with the pump component. You see that it's not measuring across that component, and therefore that one is incorrectly set up. So we know option 3 is not a viable option. However, let's look at the multimeter that's measuring current just to see how that one is also connected. The current, if we're looking at one lead compared to the second lead, we can see that current is measuring one on the positive side and one on the negative side across the component of the motor. And that's incorrect. That multimeter is set up actually to measure voltage and not current. So I know for a fact that option 3 is not correct. Moving to option 4, let's do the same process. Looking at voltage, we have a multimeter lead connected to the positive side, and we have a multimeter lead connected to the negative side. That's across the pump component. Therefore, I can say that the voltage is correctly set up. Now let's look at the multimeter that's set up to measure current. Looking at the leads, we can see that the leads are actually set up to be part of the circuit. You can see that current will flow from the negative side of the pump through the multimeter, back through the multimeter lead, and it closes out to ground. So you can see that that multimeter is actually set up as part of the circuit. Therefore, it is correctly measuring current. So our two options, option 1 and option 2, are both correctly set up. The difference between option 1 and option 2 is maybe the location of where the multimeters are connected, but they're both still connected correctly. You will have to implement this process when you connect your pump to measure current and voltage to the pump testing stations. Make sure you connect your multimeter that's measuring voltage across the terminals, the positive and negative terminals on the pump testing station, and you have your current set up as part of the circuit